Okay, so the main object of today's lesson is to talk about JavaScript prototypes, but before we get there, I'm going to talk about Java. This class that I'm teaching is for students who already had a year of Java and now they're doing a year of JavaScript, so this sort of post-APCSA curriculum. And so the first week of class, I teach the kids about classes. I'm a big proponent of classes early rather than teaching classes late. And so the first week we talk about the three parts of a class. In Java, a class has properties, constructors, and behaviors or methods. And so if we take a look at that, we could create, for instance, let's create a ball class. And a ball class might look like this. And a ball class is set up so that I have the class name, and I can have in between, let's say above the constructor, here's my constructor down here. Notice the constructor has exactly the same name as the class, and there is no return type here. And then we have we may or may not have an input parameter, but in this case I created a variable called rad for radius, and when I create a new ball object I'm going to send in that value here, and then I'm going to load it from R into rad. And so because rad is defined outside of the constructor, the scope, or where it can be seen, is anywhere inside my class. And so I might wrote one method down here, so these are methods or behaviors, and so this method is called getRad, and since rad is private, I can not access it directly, but I've created a public function where I'm going to turn the radius. And so if I say, let's go ahead and create a couple of ball objects. And so I've got ball B1 is equal to a new ball, and I'm passing the value 3. So when I call this, this is actually the name of the class, this is the name of the constructor, and when I call this function with the keyword new, this is actually called the new operator, I'm going to construct a ball object in memory, and I'm going to pass it the value 3, and so this guy is going to get a 3 in here, and then 3 is going to get loaded into here. When I make ball 2, however, I'm going to pass in a different value, in this case 8, so now 8 gets passed in. The same constructor function is called, but I'm creating a new object in memory. I still have my B1 in memory, now I have a B2 in memory, and I have this 8 that's going to come in here, so this guy has an 8. This method called getRad for each ball is going to return a different number. So I always say B1 to access a method inside of an object. I use the dot operator. So I just simply say B1 is the object, and I say getRad, and it's going to return the radius for that object. So it'll return 3 for B1, and if I say B2 getRad, since it has a different variable, and it's called an instance variable because each one of these objects is a different instance of the ball class. And so when I call the same method on B2, it's going to return the radius for that ball. Okay, so I think the first thing to say about JavaScript is that in JavaScript there are no classes. Even though we've been using the reserved word class in most of the lessons we've done up to this point, technically there are no classes. And so since we know how to make in Java, we know how to make objects from classes. How do we make objects in JavaScript? And probably the simplest way to show this would just simply be to make an object. That is an empty object in JavaScript. I just use the keyword var. I've called my object x, and I have empty curly braces. But if I go back and look at this pattern, and I come over here and I reload this page, I can go ahead and type in x into the console, and I can see that I have an object there, and it's an empty object. But wait, there is something inside of it. There is a link to this thing called proto, underscore, underscore, proto, underscore, underscore, and that is a reference to something called the prototype object. And so everything in JavaScript is an object. Functions are object, arrays are object, and so forth, and they're all linked to this prototype object. And so first of all, I have a constructor function in here. I have has-own property and some other things. Some of these are references, but that allows me to create objects without classes. And so I can create, let's go ahead and create another one real quick. If I come back in here and now, well, first of all, let's go ahead and give this guy some values. Let's say I say a:3, and so an object is nothing more than a series of name value pairs. And so let's go ahead and give this guy 2 values. I have a name A and a value 3, a name B and a value 12, and if I save that and come back over here and reload my page, now I see that if I do type in x again over here, I'm going to end up with an object. It still has the prototype down here, but now I have 2 more values. A is 3 and B is 12. So I can put anything into these values that I want. So these name value pairs, I don't just have to have numbers. I can have functions or arrays or anything else that I want. So now if I come over here and I say var y is equal to x, what I'll end up with, let's go ahead and save that. And if I come back and reload my page, I'm going to see that at this point I still have x, and I can see y now, and it turns out y is the same as x. These are actually two references that are pointing to the same object in memory, and to prove that, if I want to say y and I want to access, let's say, value a, and I say that's equal to 45, and hit save again, and now come back over here and load this. Now if I reload my page and I look at y, I can see that y has that change. A is now 45, but also x has that same, because I have x and y are references to the same object. Okay, so now we're going to talk about 4 different patterns, and I'll try to do this really quickly. The first pattern, we'll call it the object factory pattern, because in effect what we're doing is we're going to create an object that is going to be a function. So now I have ball factory, which is just a function. It's going to take in this value r, and it is going to have inside of that an object literal. So I create this variable called ball, and ball is an object literal between these two curly braces, and I just simply have one name value pair. Whatever I pass in here for r gets loaded into r here, and so I'm going to return the object. Notice inside this function, inside ball factory, I'm creating an object, and then I return that object. And so if I were to come down here, well, actually I don't even have to do it here, I can do it from the console. Let's go back to here, and we will reload the page, and now I'm going to simply say, let's say ball factory. And if I just take a look and see what that is, notice that's my function. And so if I say b1 equals new ball factory, and let's give it the value 3, and I return that. And now I say b1, I can see b1 has a radius of 3. And so that is an object in memory, and it's linked also to the prototype object, just as before. And now if I say b2 is equal to new ball factory, and this time I'm going to send it in the value 12, and if I return that, now I can say b2, and I can say b2 has this radius of 12. So I've got a b1 object with a radius 3, a b2 object with a radius 12, and that is the simple pattern for an object factory. In other words, this simply you call the function, and it's going to return an object of whatever type you want. Okay, so this next pattern is called the constructor function pattern, and it's going to work exactly like the ball factory, but it's just simply going to simplify the code. If I write function, let's just call this ball, and I'm going to pass in a parameter. So let's go ahead and pass in r as before rather, and I simply say this dot rad is equal to r. That's going to do the same thing. In effect, this creating an object and returning that object is sort of all done behind the scenes. When I say function ball, the convention is used capital B, so we're treating this kind of like a class name. And so now let's see, how do I make a ball object over here. If I come back in and reload my page, I'm going to end up with let's say b1 is equal to new ball, and let's give it a value, and if I return that, I can see that I have a ball, and it has a radius of 4, and it also has the prototype. And so if I say b2 is equal to new ball, and it has the radius 5, I'm using that same code. I'm coming up with a new ball now, and that ball has a different radius. And so I can create many ball objects, and they can each have their own instance variables, and they're all linked to the same prototype object. Let's just for fun throw a function in to that one. Let's go ahead in here and add a function and say this dot, let's call it diameter, and that's going to be equal to a function, and that function is simply going to return 2 times this dot rad. Okay? And so now, if I take a look at that and come back over here and say, let's say b1 is equal to new ball, and it has the value 3. And now I say b1 dot diam. It's going to return, oh, I spelled it wrong, sorry, b1 dot diam. it's going to give me the value 6, and so forth. So I can make many different ball objects. They each have their own function, but if I look carefully inside of this object, I'm going to see that it has a function. One thing I should say about that, a function, everything in JavaScript is an object, so a function is an object, but a function is not linked, first of all, to the object prototype. It's linked to the function prototype. But if I look inside that, the last property of this guy down here is still linked to the object prototype. And so that means I have access. Basically, my object, my ball object, has access. It inherits all the things that are in the prototype object, or I should say the object prototype, and functions inherit from both the function prototype and the object prototype. Okay, so in this next pattern, we're going to take the function and we're going to load the function directly into the prototype. And there's a reason for doing this. It's a very powerful idea. I'm going to use this ball that I've created up here, and I'm going to say ball.prototype, and I'm going to take my diam function and I'm going to add it right in here. So I'll just say diam, and that is equal to a function, and that function is going to simply return 2 times this dot red, just like before. But now I'm going to get rid of all of this guy here. And so when I do this and save it, I want to see how this changes what's going on in the program. So if I come back over here and I reload my page, I can, as before, I can say b is equal to new ball. And let's go ahead and give it a radius of 4. And now if I look in here, I'll notice that this guy only has this radius inside the ball. And if I come down here, diam has been moved to the prototype. And since that's going to work for any ball, let's go ahead and make a ball 2. So ball 2 is also equal to a new ball. This guy's going to have 12. And so now if I do that, I can say b.diam, and that guy should return 8. And if I say b1.diam, that's going to return an error message. Oh, I called it b2. So b2.diam, and that returns 2 times 12, which is 24. So the key thing is that by packing this function in here, I can make 1,000 balls, but I'm only making this function once. I'm packing in the prototype. All of these different ball objects are linked to the same prototype, and so I think in the earlier stages of JavaScript, maybe that was a bit simpler, a simpler way to do it. It was a way to conserve memory. I think with today's computer systems, maybe this isn't so important, but we can put things in the prototype. Finally, the way we've been looking at balls or creating things up until this point is with the classical pattern, and to do that I need to put up on the top use strict, and I think that really depends on your browser, because I've noticed in Chrome I don't have to have that. Chrome just sort of knows if you're using this new classical pattern, but in this case I can use all of those patterns we had before. So let's just take a look. This student of mine had a class mover, and there's a constructor function. There's no this here anymore for these function names. I just say draw and update and so forth. And so if I'm going to do that over in this, I'm going to simply say class ball. I've already got a ball. Let's comment this guy out for the time being, and I'll say class ball, and then I'll have a constructor function, and I'll say constructor. And so this looks like Java. And the point is that this is just giving you the appearance of Java, but behind the scenes it's going back and sort of transpiling it back into classical JavaScript, and it doesn't do any of, doesn't really have any classes. So I'm going to go ahead and put the constructor 3 in here, and I'll say this dot rad is equal to, and I did it again, let's go ahead and just make this an R, and I'll go ahead and load that guy in here for R. Sorry, get rid of this R, and we're good to go. And so that is an example of using, I should put this guy in curly braces, and I can have functions in here. So if I wanted to have a diam function in here, diam, diam, and that function is simply going to return 2 times this dot rad. question is, where is this putting it? Is it putting it in the prototype or not? And so let's see if I don't have any errors in this. Let's go back in here. We'll reload the page. And let's say B is equal to new ball. And let's go ahead and give it the number 44. And now I have that. And notice that it took the diameter and it put it in the prototype for me. And so it's treating it exactly as if I was using that prototype syntax. But in any case, let's go ahead and take a look at this code. And so I have 4 examples, 3 I made and 1 I borrowed. First of all, let's take a look at this. This is the code from a book called, I think it's Supercharged JavaScript Graphics. I should probably put the author is right here. And he used a method where he created a variable. Vector2d is a function. He passes in 2 values, and he simply is saying he's creating a vector. So this is the factory method. So this is the, let's say, original JavaScript. This is the method we would use to do it, and he put all of his functions in here. Notice that this is a name-value pair where the name is scale and the value is a function, separated by a comma. Just as before, his add method, same thing, a name-value pair where the value is a function, separated by a comma. And so that is using the object factory method. And then over here we have JS Vector. This is the project I did with my kids, and so they did it earlier in the year where they did they created simply a JS Vector object, and all it has is 2 properties, but then they added all of these methods into the prototype. So I could have 100 different vectors in my program. They each have their own X and Y property, and they are all running these methods from the prototype that they're all linked to. And then finally over here we have JS Vec. That's the one I've been using in the project that we've been working on. And JS Vec uses this class notation. And I think I had one more where, yeah, let's do this one. So this is using a constructor. And basically it takes in these 2 properties and all of these functions are being added. And so we can see how this would, we can create vectors from each of these and see how they would look different. Some are going to have these methods loaded in the prototype and some are not. Okay, so in this last bit we're going to look at each of these 4 functions. We're going to go back to our project and we're going to think about how to make vectors with each of these 4 classes. We don't need 4 different ways to do it, but the key thing is that we understand how the prototype is being used as a way of creating a pattern from which we can link our objects. And so instead of in Java where we made a class and then from that class we made objects, in JavaScript we make objects directly, but then we have this pattern called the prototype, and we can have other objects linked to that same prototype. So let's go ahead and make one of each of these just so we can see how this works. So I'm going to make a vector2d. So let's go ahead and say var, and we'll say v1 is equal to new, and I'll say vector2d. Vector2d. And this guy is going to give it a couple of parameters, 22 and 33. And so I'll take this guy into my save it, go back and run the program, and let's just take a look at that guy. So I've got that guy v1, so if I say v1, I should be able to see that yes, in fact, I have this guy in here, and notice that he not only has values, these properties 22 and 23, but all of the methods are getting loaded into the vector itself. So if I have 1,000 vectors in my program, each one is going to have its own copy of each one of these methods. Okay, let's go ahead and look at the constructor function. The constructor function was going to be very similar to this. So in this case, I'll say var v2, and again, we'll take a look at that. The constructor function is where we say function, the name of the essentially what looks like a class, and then we're passing in these values, but notice I have this dot add, this dot sub, this dot get new, and so it looks like it's going to be working the same way as the object factory. And so if I say convec, and let's go ahead and give it 33 and 44, save that and run it. So now we'll go ahead and take a look at v2. Reload, come over here, v2, and sure enough, I've got the same thing going on. I've got all my methods are inside each individual vector, and I have these properties 33, 44. Notice that in the prototype I still have my prototype, but I don't have any methods that I've created in that prototype. Okay, let's do the next two. We've come back over here, and now we'll take a look at JS Vector. This is the one my kids did, and so this is using JS Vector, which is a function. I'm only loading the two properties in, but I'm loading all of the methods in to the prototype. And so in this case, I can say var, let's say v3 is equal to new JS Vector. And let's give it 55 and 66. And so now I'll save that. Let's see where it puts those methods. And so if I say v3, sure enough, inside the vector I only have those two properties, and all of the methods I've created are being built into the prototype. So that means that all of the vectors that I create, all of the vector objects that I'm creating, each one have their own instance variables, x and y. It can be set to whatever value you want, but they're all sharing the same add, get direction, get magnitude, and so forth from the vector class that's been loaded into the properties. And then finally, this last one, which is the JSVec, this is where we're using the classical syntax, and this, we have the reserved word class, and we have a constructor, and we're adding these guys. Are these getting added into the prototype, or are they going to stay in the object itself? And so let's go ahead and try that and see. So I'll say var v4, and so this is going to be equal to a new JSVec, and let's give it the values 77 and 88. And so I'll save that and come back, and I'll see what v4 does. So v4 turns out it's going to work just like that prototype method, where all of the methods I've created are getting added into the prototype. And so that's what's going on with JavaScript. Again, I make objects directly. They're all linked to the prototype. If I'm calling a method on one of these, on let's say a JSVec object like v4, I have access to everything in here because I inherited it from the prototype, and so on and so forth. I have all of these. So I have the way JavaScript works, it works on this process called retrieval, where I'm going to first look for, if I want to, for instance, get something value of, I would first look here. If it's not here, I go into the prototype. And the prototype object that I've created here is linked to the object prototype. And so I keep going down the prototype chain looking for whatever I've called, whatever method I've called, whatever value I've called. And if I find it in the prototype chain, anywhere in the chain, I can use it because I inherited it. If I can't, I'll get an undefined. So that's it for today.